Hi, this is Austin with Radical STEM Tutoring, and today we're going to find out how much force it takes to push a 100 kilogram box. Okay, so let's state some things about this problem. Let's say that we're going to move this a total of 10 meters from where we started. We'll get it up to a maximum speed of 2 miles per hour, or about 0.89 meters per second. And we'll say that this is a wooden crate on a concrete floor, so our coefficient of friction will be about 0.6. Now the things we want to find out are how much force does it take to move this, and how much work do we have to exert to move it that amount of distance. We can do this by looking at the net amount of work done on the crate, and that's going to be equal to the work that we put onto the box as well as the work that friction does on the box, pushing back on it and opposing the motion. So that'll be minus the work done by friction. Now with what we have provided, we should be able to calculate the work done by friction and the net work done. So once we have both of these, we'll be able to see how much work we have to exert on the box to move it this far, this fast. So first, for the net work, we can make use of the fact that the net amount of work done on an object is equal to the change in its kinetic energy. So if this box started at rest with no kinetic energy, then the change in its kinetic energy is just equal to how much it has while it's in motion, and that will be based on its mass and its speed. It's 1/2 mv squared. So if we calculate this based on the 100 kilogram mass and its velocity of 0.89 meters per second, that will come out to 39.6 joules of energy. Now to find the work done by friction, we'll use the definition of work, which is that it's a force times a distance. So here, this force will be the force that friction puts on the box to oppose its motion, and the distance will be the 10 meters that we move it. Now remember that the force of friction is equal to the coefficient of friction that we have down here times the normal force between the object and the floor. Now, on a flat surface, the normal force will always be equal and opposite to the force of gravity on that object. So now we can just plug in all of these numbers to get the total work that friction does on our box. And if we use all of these values, that will come out to the work done by friction being equal to 5,880 joules, which as you can see is a lot bigger than what we got for the net work done. So we already did the hard part. Now this is a one-step algebra problem. That's the great thing about problems with work and energy, is it usually comes down to some very simple algebra. So in this case, we'll just add 5,880 to both sides. To get that, the total work we need to put on this box to move it is 5,919.6 joules, or 5.92 kilojoules. If we take this back to the definition of work being a force times a distance, well, we have the amount of work that we just did, 5.92 kilojoules, and we know that it's being applied over a distance of 10 meters. So if we divide this by 10, we'll see that the force we need to put on this box is equal to 591.9 newtons of force. That can be a little bit hard to interpret because most of us aren't used to working with newtons in relation to how hard we push on something. But from the Canadian Centre for Occupational Health and Safety, that's a mouthful, they suggest that with your whole body being involved in the motion of pushing something in the workplace, it is not recommended to exceed 225 newtons of force. So if you have to move something like this, it's probably better to get a dolly or a pallet jack or a friend to help you move it. Alright, if you found this video helpful, please be sure to like it and share it, and have a radical day.